Describing pairs of angles. Obviously, you're not going to be talking to your neighbor because you're at home or somewhere else. So a square is divided by its diagonals. The diagonal goes from corner to corner into 4 congruent triangles. So what it's saying is this triangle here is congruent to this triangle here, this triangle here. Oh, look at my lovely artwork. That triangle there. Those are all congruent. I know you're thinking, why did you not become an art teacher? I know. It's okay. So, find the values of each of the variables. Do not use a protractor. All right. Well, if they're all congruent, and this angle here is 90 degrees, that's what that symbol means. We talked about that before. That means if they're all congruent, all of these angles are also congruent because they're kind of, if you think about the top of the triangle, if you laid it out. So E, C, and D are all 90 degrees. Okay? And then here, since it is a square, that's 90 degrees right there, and A and B are equal to each other, is bisected, so 45 degrees. So let's talk about angles. Complementary and supplementary angles. No, your computer's not freaking out. I just changed the aspect ratio or the view, zoom. So complementary and supplementary. I used to always get this confused myself when I taught this, and I always had to remind myself before I taught the lesson years ago. And I finally realized C comes before S in the alphabet, just like 90 comes before 180 as numbers. Okay, so remember that, because complementary angles have a sum of 90 and supplementary have a sum of 180. Now, these two angles can be combined and touching like this, or they can be two totally separate angles, just 170, 120, that add up to 90. All right? They don't have to be touching. If they are touching, then they are what's called adjacent. And if you think about it, if someone is adjacent to you, they're next to you. All right? And if they're adjacent, they share a common point and a common ray. Notice here in the second example, those points are two totally different points, and they don't share a side or a ray. Okay? Same thing for supplementary. Here, they share a common point and a common ray. Here, two totally separate angles, not even touching, but they still add up to 180. All right, in the figure, name the following. A pair of complementary angles. Remember, C is going to be 90 degrees. So we need two numbers that add up to 90. Well, obviously, we're not going to use 127 at all because it's bigger. So there's really not too much of a choice, but let's just confirm that 53 plus 37 add up to 90. They do. So we're going to say 53 degrees and 37 degrees. Now supplementary. Obviously, these two do not add up to 180 because they don't form a straight line. And we know 37 and 53 don't add up to 180. They add up to 90. So there, again, there's really only one choice, but let's confirm that these two add up to 180, which they do. So that would be 127 and 53 degrees. Now, we have to be careful here. A pair of adjacent angles. That means touching, all right? Well, this one is all over here by itself, so we're going to ignore that one. Obviously, it's the one on the left, but how do we name them again? Again, we always start off with the angle symbol. This letter, the A, the corner, is always going to be in the middle. Remember that. Very important. And now we just go C-A-D. Again, we also could call it D-A-C. It doesn't matter. And then for this one, C-A-B, or we could call it B-A-C. All right, number 1 is a complement of 2. If number 1, angle 1 is 62, find 2. Well, complement again means 90. So all we need to do is do 90 minus 62. So we're going to borrow, that's 8, that's 2. That would be 28 degrees. Supplement, remember, is 180. So if one angle is 47, we're just going to subtract that from 180 and find out the supplementary angle. So we're going to borrow again. We're going to get 3 here, 1 here. So that is 133 degrees. Remember, anytime if I'm going too fast, just hit pause, rewind, whatever you need to do. All right, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure BCE, which is this one right here, BCE. That's the larger angle. Going back to the last lesson, that's obtuse. And then ECD, which is the acute angle. Now, if they're supplementary, that means the two of them combine to 180 degrees. Combine, add up to. So all we're going to do is say this plus this. 4x plus 8, that quantity, you don't have to put in parentheses, but that quantity plus this quantity of x plus 2. The parentheses don't do anything because we're adding, but I'm just showing you the grouping. So now I'm going to join like terms. 4x plus x is 5x. 8 plus 2 is 10. That's supposed to be a 0. Equals 180. I don't know why I have that. Looks bad. Looks like 110. So 10. We're going to subtract 10 from both sides. That's going to give me 5x equals 170. And then I'm going to divide by, no, I'm not going to divide by x. That's just silly. That makes no sense at all. I'm going to divide by 5. And that's going to give me x equals 34 degrees. Okay? Or actually x just equals 34 because we're not finding an angle. We're just finding x. Now, remember, look what the problem is asking you to do. Is it asking us to find x? No, it is not. It's asking us to find this angle and this angle. So we need to plug that 34 in right here and right there. All right. So I'm going to do the smaller one first because it's easier. DCE, angle DCE is x plus 2. Well, I substitute the 34 in, 34 plus 2, and that gives me 36 degrees. Now I have two choices. I can plug in 34 to 4 times x plus 8. Or I can quite simply, since I know they're supplementary, just subtract 36 from it 180. It makes no difference. It's just faster to do the subtraction. BCE. So if I do 180 minus 36, I get 144. And those two add up to 180, so they are supplementary. Again, I could have done 4 times 34, which would have been 136, and then added 8. It makes no difference. Your choice. All right. Linear pairs and vertical angles. So if two adjacent pair angles are a linear pair, all right, they are forming a straight line, hence linear line. All right, so we already talked about they share a common point and a common ray, and then you have the two non-common sides. All right. Two angles are vertical angles when they're opposite. So when you draw an X, any kind of shape of an X, this angle and this angle are vertical, and this angle and this angle are vertical, and they're also going to be equal. They're going to be congruent. So identify all the linear pairs and all the vertical angles. Right. So linear pair is tricky because we can only use two. So if you look here at this line, it is made up of angle 2, angle 3, and angle 5. They do form a line, but a linear pair only has two angles. Therefore, we're going to go to the other side and take this angle and this angle. So 1 and 4. Now, if you notice, we also have a line right here. Okay, that is made up of angle 1, angle 2, and angle 3. But again, linear pair only uses two angles, so we're going to go on the other side and say this one and this one. So 4 and 5. Now, vertical angles. We got to try to find an X in here. So if we go in here and look at this line, and this line, we have an X. And therefore, we have this angle and this angle, 1 and 5. Those are vertical angles. And that's our only choices for vertical angles there. All right, two angles form a linear pair, which means they form a line. So right off the bat, you can draw a line. And draw a ray. Now, this may not be to scale, all right? My two angles may not look like this, okay? It may end up looking totally different. Like it may end up looking like, oh, it's a really small one and a really big one, and it should have been drawn like that. It doesn't matter. You're not drawing this to scale. You're just getting an idea of what you're talking about. So you have an acute angle over here and an obtuse angle over here. The measure of one angle is 5 times the measure of the other angle. Well, let's think about that. One angle is 5 times the other, so one angle is small, one angle is big. So if the smaller one is x, this one is 5x. Okay? So I'm going to take 5x plus x, because remember, linear pairs add up to 180. Well, that gets me 6x equals 180. Divide by 6, x is 30. Okay, so this is 30 over here. Now, that angle is not 30 degrees. Okay, that angle is more like 50 degrees. It doesn't matter. We're just getting an idea of what we're solving. So if that angle is 30, then the other one over here is 180 minus 30, which makes it 50 degrees. So my two angles are 50 degrees and 30 degrees. How do we express a complement or a supplement when we don't know the angle? All right. Well, the measure of an angle is twice the measure of its complement. Find the measure of each angle. Okay, so we have two angles. We have angle 1, okay, and remember, complement means they're going to add up to 90. Okay, so it says the measure of an angle is twice the measure of its complement. Okay, so we're just going to put like, say this one's x. This angle here, we don't know what it is, but it's going to be 90 minus x. So again, if this was 10, 90 minus x would make the other one 80. If x was 30, 90 minus x would be 60. So again, you'd have stuff like this, 10 and 80. That's supposed to be an 80. 50 and 40. Okay? To find a complement, you would just do 90 minus whatever the first number was. Okay? So it says the measure of an angle is twice the measure of its complement. But we want to have one more stipulation, that the other angle is twice the measure of the complement. So this angle is equal to twice the measure of the complement, which we just talked about would be 90, whatever that is. All right, so if I just do some algebra, that's going to be 180 minus 2x. I'm going to add 2x to both sides. That gives me 3x equals 180. And when I divide, I get x equals 60. So if one angle is 60, the other is 30. And this angle here is twice its complement. All right, last page, you can read yourself, but real quickly, this is saying things you can conclude from a diagram. So all of this right here is stuff you can deduce from looking at that diagram, all right? And then these are things you cannot, all right? If you wanted to make those, you would have to have more markings on them. So you can't assume A, B, and B, C are equal unless you have the markings, okay? They look up here equal, but you can't assume that unless they're marked that way. You can't assume ABD is a 90-degree angle unless it's marked. We talked about that in previous notes. It ended up being 89. You never know. So the key to geometry is never assume. That's it.